Okay, we're going to quickly finish up this the notes for writing functions. We have this one part here. It's actually task 8.5 Go, I believe is what this one is. So the topic is vertical and horizontal translations. Actually, we've only talked about vertical translations so far, so we're going to try to see what we can learn about horizontal translations real quick. We have here a graph of f of x equals 3x. That's what this graph is. It's labeled f of x, so it has a slope of 3, 1, 2, 3 over 1. It looks good, and a y-intercept is 0. What we want to do is sketch the graph of g of x, which is 3x minus 2. So gx equals 3x minus 2. I know it has this same slope. So y-intercept is minus 2, up 3 over 1, up 3 over 1. I'm going to do a couple, I guess I'll just do one more going the other direction. I'm out of space. So this is a graph of 3x minus 2. I'm going to label it g of x. 3x minus 2. They look pretty close together, but the vertical difference is actually minus 2. Alright, next one. I want to sketch the graph of h of x, which is 3 times the quantity x minus 2. So before I can graph that, I need to distribute this 3. So this is going to give me 3x, and then 3 times negative 2 is minus 6. So h of x is 3x minus 6. Again, it has the same slope, but now my y-intercept is negative 6, so that's 2, 3, 4, 5, 6. It's down here at the bottom. I'm going to count off my slopes. Up 3 over 1, up 3 over 1, up 3 over 1. That'll do it. Connect this one. So label this one h of x. So we have f of x, then g of x, and h of x. Let's describe how these are different and how these are the same. I think the easiest thing to figure out how they are the same is with their slopes. They all have 3x in the equation, which means the slope is 3. So they all have slope equals 3. If you want to think about this being 3x plus 0 and then minus 2 minus 6, g and h are both vertical translations of f. So they, actually g and h, are vertical translations of f. Right? They're just up and down from there. And let's see, what is different? What is different about them is, pretty obviously we can see here, they have 3 different y-intercepts. So different is the y-intercepts. Y-intercepts are 0, negative 2, and negative 6. Alright, I think that's pretty good there. Explain in what way the parentheses affect the graph for this one, for part B. 3 times the quantity x minus 2. Let's write this. H of x equals 3 times the quantity of x minus 2. So in this form, for h of x, which is down here in purple, the y-intercept is not minus 2. You have to do the distributive property in order to get the y-intercept, like that, okay? But I want you to notice something. The vertical translation is minus 6 from f all the way down to h. So we don't need to worry about g in this case, but f all the way down to h, all the way down there to there, is a vertical translation of minus 6. I want you to think about this. In parentheses shows us the movement in a horizontal direction. We can think of this as a horizontal shift, and it's a horizontal shift of plus 2. So we use actually the opposite sign of this. So it's a horizontal shift of +2. So I'm going to go from here to here, and I'm going to go 2 units to the right, and that puts me right on h of x. So 2 units to the right, which is a part that was in parentheses, is the same as the distributed version 6 units down in the vertical direction. So basically you have to take into account this horizontal shift has to be impacted by the slope before you can talk about the vertical shift. So if you have parentheses, you can think of it as a horizontal shift. If you don't have parentheses, think of it as a vertical shift. Kind of interesting fact about that. You'll certainly learn more about that in Math 2 and Math 3. Alright, that finishes up the notes. If you have a couple of pages of homework to give a try to, please submit those on Canvas. Bye now.